And then we'll do it this way. On the screen, we got what we're doing today. The tests, I gave almost all of them back. There's one I got to do for someone in Zoom. So I'll do that after class and send it out. In general, really good. Okay. Couple things you got to watch once in a while, but in general, the marks were all right. Okay. So we'll keep that going into the next part. What's coming up? What we see on the screen is slope of the line. We're going to see a few different things with it. See how to calculate the slope of the line, how it looks on a graph, when it's positive, when it's negative, that sort of things like that. Okay. So we went over this a little bit on Friday, but what we'll do today, just as I said, do it official like. Who has seen this topic before? It's a show of hands. Yeah, slope for me on Friday, but even before that? Yeah? Perfect. Okay, that sounds good. Anyone else? Slope of a line, y2 minus y1, given by this formula here. Yeah, because what happens is, this is going to be our lives for the next little while. Lines in math are super important. And so we're going to draw them. And then we're going to see just how steep they are with one another here. Right? How steep is one feature that we can look at. Does it go up very quickly? Is it like that? Or does it take a long time to get going? Is it like this? Okay, so this formula here helps make that happen. What happens is there's usually going to be 2 points. Everyone's okay with the x value going left and right? Y value going up and down? Okay, so this could be 0.1. And so it has the x and y values of 1 and 1 with it. This is 0.2 over here. And so they'll have a little 2 along with the x and y coordinates. Okay, something to get used to. Now then, oh yeah, this first example. What it shows is that, we'll come back to this at the end, but sometimes if you divide by 0, this might show up in this type of work. Dividing by 0, it could end up being a result that looks like this. It's given a special word. So first of all, it's called undefined. It's the English word for it. And what it means is that you have a vertical line. And a vertical line is one that goes up and down like this. Straight up and straight down. Not at an angle like the ones you saw at the start there. Okay, so this is sort of a special situation. It'll come up a little later on, officially later on. The universe doesn't explode, but it's different than everything else. For vertical line, there it is. Yeah. Okay, but check this last day. Is everyone okay with how the coordinates on the XY axis all work? -3 and all that. Okay, perfect. So there they are. So it's possible now to find the slope between any of these 2 lines just by connecting them, drawing a line through them, and working it out. Okay. Showed this last day. This is the reason why we do it. What happens is it's important in math, science, various applications to be able to find the equation for a certain situation. If you find the equation, you become the hero. All right, does anyone recognize this? Yeah, Einstein. Crazy hair. Looking a little like this. Really smart guy, right? You see? How do you know him? Not just from the picture, but from the formula he made, right? Forever. Does anyone know this one? At least here in the West, maybe you have some a different name for this for somewhere else. F equals ma. Who did it? It's a big F for force from physics there. Nice. They were like in centuries apart. Newton was the guy, and maybe an honorable mention is Galileo. He was actually doing the experiments beforehand, right? So Newton, what did he look like? Kind of like this, big, long, swoopy 18th century hair. Looked like an 80s rock star, actually, more than anything like that. All right. And we use this stuff that these guys did for, basically everything we have in our modern world. The buildings we create, the cars we drive, a bunch of different things. Okay, and so where do these lines and, or rather, where do these equations and such come from? Yeah, work like this that you do in science class, okay? You get your data points and you try and find the line that fits the nicest, the line of best fit. Then you can find slope and stuff about it, which is what we're doing today. Just that one piece. This is more about science class. The X values are the independent variables and Y are for the dependent variables. But the two classes, they overlap nicely, so mention this here. There's a graph of it showing independent variable down there, dependent over there, independent along the X and dependent along the Y. This is super important, comes up with one of the things we got today. You might be given the equation of a line. So just for free today, I'm going to tell you that a line equation given for free looks like this. Y is equal to some number plus some other number. Or maybe something like this. Y equals 5x minus 2 over 7, like that. Right? The thing for today, because we're looking at slope, right? This slope information is inside of this equation somewhere. For those of you seen it before, anyone, can anyone tell me where it is? Or yeah, try and decipher the screen that's up there. That also gives it away. Yeah, so I heard AX plus B here in class, right? I learned it as MX plus B, and some people even MX plus C. Okay. The thing is, where is the slope hidden in broad daylight here inside of this equation? Hey, it tells you the slope is M right on the screen there, right? Now, importantly, where in the equation then is it going to be? For that one, it's 5. Going down, yeah. So we have is first of all, where can you find the slope? It's always going to be the number in front of x when the equation is set up like this, y equals ax plus b. That's the slope there. That's the slope there. That's the slope there. Okay, always true all the way along. Okay, so it's very nice. No calculations to do. Just make sure the equation is set up in this way and read the number off. So the slope here, 2/3. Slope here, equal to 5. Right? Which line is going to be steeper? The 2/3 or the 5? Steeper, yeah. So we got two lines. One goes like this, it's shallow. And then one goes like that, it's steeper. Steep, shallow. Right? If you're going for a hike, a nice shallow hill is very comfortable. If you go on a steep hill, oh, your legs are going to start burning, right? Okay. So looking at these numbers, which one's the bigger one? 5, of course, right? So 5 is going to be the steep hill, and 2/3 is going to be the shallow hill like that. Okay. More on that later on, but just to give you an idea what it means. The other stuff we'll get at in the next couple of days. Just slope only for today. Okay, so this is like just a cleaner example of line of best fit from science class. All right, you got your points there. You draw it through and try and calculate the slope. We'll do one of these in real life so you can just see a worked out example. But this is just to show you, honestly, different styles and different places that they come from. Okay, just another situation, bunch of points. So the line doesn't go through them all, but close enough, right? In grade 10, I think you guys can use your eyeballs to just make the best guess possible. And there's in professional life, there's a big math formula that shows how to get it. Okay, maybe we'll get there. We'll see. This is an application of it. If you're making money, that's the revenue. And the cost is the money you spend in order to make a product of some sort. So I think the answer or the example I gave last day was what? Let's just say a marker of some sort. There it is, red marker. I don't know if you know it, but it costs $1 to make one of these. And because they're in such high demand, you can sell them for like $4. Right? And so what you can do, right? This is for each. So you can imagine that if you have the costs and then the number of markers, looking at this separately, for one marker, $1. 2 markers, $2. And you can see the line. 3 markers, $3. You can see the line growing right in front of your eyes there, right? And similarly, if you sell them, you can do the same. When you sell one, you get $4 coming in. When you sell 2, you get $8 coming in. And again, you can see the line starting to be created, right? Okay, so what has to happen? You want to sell these things in order to make some money. And this helps you figure out how many markers you need in order to in order to need to sell in order to make a profit. Okay. Another example, just with some numbers in there. All right. So sometimes the points will be given to you, and sometimes you're gonna have to read them off the graph in order to work out the slope. So these ones are all given. We'll just do this one for practice, so you see one that's worked out. What is the slope of this line that we're looking at here? Okay, so the first thing to do is you choose nice points. Go easy on yourself. Sometimes these lines go through corners and halfway through squares and stuff. Choose ones that are easy to read. Okay, so taking a look here. Oh, class, can you see those? They're pretty small here. Oh, and by the way, all we need is 2 points in order to create a line here. Okay, I'll help you guys out. 1 and 5? Yeah, 2 and 10, if you look super close, is one of them. Yeah. 3 and 15 as well. Yeah, for sure 1 and 5 is there, but guess what? To calculate the slope, we just need 2 of them. Yeah? So we choose those 2. And what we then do is we can put x1, y1 in there and x2, y2. That's if this is, yeah, actually do this. It's a good useful step. Officially, what's that? The slope? I think so, yeah. From class, someone said the slope is 5, so we'll just check that out. Gonna put the x1, y1, x2 in there, right? And y2. It doesn't matter where officially which point is x1, or which point is point 1 and point 2. But I'm always just gonna go left to the right. Okay, so that means here we got the point 2 is gonna be x1. The 10 there, that coordinate is gonna be y1. The 3 is gonna be x2. And then the y is gonna be y2, just like that. With that careful bit of work done, that careful bit of reading, just straight up substitution, boom, and then you work it out. That's number 3. And yeah, Peter, I remember that you had a question similar to this last year in English class. I think so, yeah. Not this slope, but related to, yeah, anyways, we'll chat about that. The calculation here for the slope. Notice M here in Canada, I think America too. Not sure why. That's just what it is. Okay, it's always going to be the y values are on the top, and then the x values are on the bottom. Okay, so being careful with the substitutions, I'm going to say if everything's positive, you don't need any brackets. But once you start getting negatives showing up, put the values in brackets so that no drama occurs, okay? That we get the signs correctly when we do this. Okay, so what do we got for y2? That's our 15, y1 is our 10. Just reading off from the good work we did earlier. Then we got x2 like that and x1 like that as well. 5 indeed. 3 minus 2 is the 1. That can disappear. And so, yes, you get a slope of 5 for this particular situation here. Okay. To up the level a little bit, we could pay attention to the units as well. So notice for the units, that's like meters and seconds and stuff. In the Y direction, what are the units that are written there? Pretty small for class, so Zoom, maybe you can help out.
Why?
Yeah, the Y axis there. What are the units? Those are numbers. What do those numbers represent? Number of chickens?
The band,
What's that, Zoom?
the band number and the band.
No, at least I'm not understanding it, Zoom. I'm not sure there.
So, yeah, I'm quite confused.
Class? Oh, no, the units are. So units, this is more like science in a way. Meters, seconds, kilograms, dollars, amounts, 10 apples, for example, right? So for the Y axis, what are the units for the Y axis that are there? Number of apples is part of it, but I think that's on the, yeah, that's the one that's easy to read. That's the X axis, right? Number of apples. Can't, eh? If I make it bigger, I think I'll have to go back to the start. Let's see if I do that. Cost. Right? So if something costs, if you're looking at cost, what are the units for that? Cost is Y for sure, but it's going to be in the units of dollars or thousands of dollars or something like that, okay? And so that means, watch this. For our slope, we had, that was Y over X, right? So for the units, that's dollars, the cost, and then the bottom is the amount. And so this slope, what it ends up being is $5 per apple, or in other words, $5 for each apple. Oh, off the screen there, eh? Well, that's no good. Let's do it like this. Okay, so I pointed out that the slope is Y over the X. The units are dollars for the Y. The amount is, the X-axis is the amount. So what we actually found for the slope is that the cost of each apple is $5, the Y unit, per apple, okay? The units for the bottom. So we'll see more word problems later on. So we'll get a closer look at that, but just a little mention for it today to sneak it in there. Okay, for today, we're just doing the calculate, making sure we can read graphs, read equations, work some points. Okay, so what do we got next here? Oh, that was nice. Closer look. I've forgotten. Should have had this earlier. There, it's very clear now. The cost is along the Y-axis, right? My bad. Sorry about that. Okay, this is just another example. clean line going through, we could calculate. This one here, let's do this one, and we'll pay attention to the units as well. So the goal is to find the slope of this red line that's here. And so have to choose 2 points to get this started. 4. Yeah, it is actually. From class, we got 4 and 4. Huh. How about that? All right. 9 and 9. And okay. Very nice, easy numbers for this one. Okay. That looks good. What happens next? For free. Yeah. Perfect. So someone in class said X1, the next two, well, or almost. Whew, it was close. So X1's always first, right? And then Y beside it. Because it always gives, do you go in that way? And then like that. Or, oh, you go this along the X and then down or something like that. X and then Y. Yeah, perfect. For free, the formula is right there, unless someone can beat me. What do you got? What is it? Oh, it's on the screen?
5/9.
Yeah, it will be. We'll put the numbers in, but I'm always going to start with the formula. I'm just that way.
9/9 minus 4.
Yeah, not bad. Yeah, true. So 2 different ways to think about this. Someone said on Zoom, they looked at this 1 point, and so it's 9/9 because those go together. Y is on the Y coordinates on the top.
And minus 4/4.
Yeah, and then subtract, and then 4/4, right?
Yeah.
No brackets because everything's positive, but yeah, put brackets in and remember all those strange rules.
Mhm.
Minus of a minus makes a plus, and that's the main one actually. Oh no, and also subtracting minuses.
So
Yeah, good. So we got this. So the slope ends up being how much?
zero.
5/5 is a middle step. Finally, just 1 there. That's right. But let's include the units as well.
How it's 5/5?
How 5/5?
Oh, we have to minus them.
Absolutely. 9 minus 4. That's what
Yeah,
the
yeah.
formula says. Yeah.
I thought we have to divide them.
So you got to watch your orders of operations. What you do is whenever something is a fraction, there are invisible brackets there. So you
Oh.
work out inside the brackets first, and then do the dividing after.
Mhm. Okay.
Okay. Now, for the units, it's always going to be, remember, the y over the y-axis over the x-axis, right? So on the y-axis, we got time. And what do we have on the bottom?
Distance.
Yeah, I think it says distance, right?
Yes.
Okay. So just for free, I'll tell you that from physics class, when it's time, it's usually seconds. And then when it's meters, gave it away. When it's distance, it's usually meters. So a good looking final answer like this would be 1 second per meter. That would include the units for this particular graph, as well as the slope, the number that we're calculating there. Okay, I love how the math and the physics come together. This one you can try on your own. Just a nice good looking graph there. Units as well. Dollars in tiny writing. Time along the bottom. You can't see that one? I can't see that one. We'll do the trick. That one's on the top. Yeah, perfect. Oh, you know what? It might even be on the next screen. What am I doing? I should check first. I did that for the other one. Did I do that for this one? No. Okay, so I'll bring this back up. So there we go. Yeah. That's nice, eh? Well, they only show 1 point. You can kind of see at the 3-hour mark, right? But we are allowed, we are able, and we need to choose points that are on the line. And so we can choose any 2 points that are on the line. And so let's choose nice ones as usual, right? I think that first one there says if you work 3 hours, how much money do you earn? 60. That's not bad, especially if you're in high school. It's pretty good. 60 bucks. Oh, you can't see that? It's true. I can't either. 3 hours, you work 3 hours, you get 60 bucks. Yeah. Yeah, and so you just need another point. So 2 hours and 40, is it easy to read? Yep. Let's use those ones. 2 hours for 40 bucks. If the points are all weird as opposed to nice like this, maybe choose them far apart from one another as opposed to close together. But super fine for this. Oh, still can't see it. Super fine for this situation here. Yeah, question from class.
In this question, like y2 and x2 is like for 3 hours, right? Because it's going to be upper than that, or
Yeah, question in class about which one's X and which one's Y and all that, right?
no, which one is x2 and y2 and this one is this one and y?
Oh, good. So the question for class, which one's X1, Y1, which one's X2, Y2? Officially, it doesn't matter. Okay. But the X, where the X goes does. So is the X going to go with the hours or is the X going to go with the money? X is with the money or the hours for sure, right? So I'll show you a different style. This is called a table of values. You might see it like this. Table of values like that. So when we had X was 3, Y was 60, 2, Y is 40. Yeah. We can. I just want to show you a different style again. Like this will be coordinates then, right? Like we've seen already. So the X comes down. 3 and 60 will count as 1 point. And then, yeah, 2 and 40 count as the other one. And so now officially we can put in our X1, Y1 and all that and get us through to the end. So notice it doesn't, officially it doesn't matter. This one's reversed from, I think, our usual. Usually small numbers first or left side first, right? So
For this question, I think it's better to be said y2 and x2 is for 3 hours and 60
yeah, I think
because
it'd probably be easier because of the time.
because it's going to be minus if we do.
It's true. From class are just suggesting to switch these around, put that as the first point, and this one as the second. That way you avoid the minuses. But listen, how tough is that? What's a negative divided by a negative? Positive. See, you can handle it. You got the goods. Okay, so just to show you this calculation now, right? Formula first. But just to move on with our lies, or no, we'll do it. Formula first. We got, which one was Y2? 40. It's off screen, but trust me. 60. See, in this style, yeah, we will have our, and I kind of like what I heard on Zoom. Put the points that, the coordinates that match. That way you kind of focused on one thing all the time.
20 over minus 1, and it's going to be
Yeah,
20.
minus 45.
nice. Zoom got it right. Jumped right in there at 20 with our negatives divided by negative there, right?
Yeah.
Yeah, perfect. Yeah, exactly. So it's something that's special about a line that I haven't said, and that for a line the slope is the same everywhere. So we chose 2 points to get this slope. Worked it out. If you happened to choose 2 different points, you get the same answer. The line you can see on the screen when I let it there, it's got the same angle, right, all the way along. Same steepness, if you like, right? So that means the slope is the same everywhere. Any 2 points. You choose 1 and 20, 6 and 120. Slope is 20. Just done like that. Oh, not bad. So from class, they're asking about Y3 and Y2 and such. So watch. This is how that stuff works. When we got, so you can see it, when we got points on a graph, okay, well, and I'll use the same graph. It was 1 and 20, right? And then it was 2 and how much? 40 we just used, yeah, and 3 and 60, right? Okay, so in real life, this is probably 0.1, 0.2, and 0.3, right? So the coordinates for this point would be 1 and 20. What are the coordinates for this point? 2 and 40. Over here, 3 and 60, right? Not for our example now. Then I'm referring to the one that's on the screen as well. And yeah, you take a look. It's 1 and 20. Okay, so then if you want to find the slope with, let's say, these 2 points, yeah, there's 2 different ways to write it down. You can just use the regular formula, y2 minus y1 over x2 minus x1. And you call this x1, y1, even though it's 0.2, it doesn't matter. x2, y2, right? You do it. Or, we'll do it in red. If for some reason, maybe this is a little more mathy, that's for the first point, you got 1s. For the second point, you got 2s. Oh, for the third point, you got 3s now, right? So then how do you find the slope if you're using these symbols instead? Again, those 2 points, it'll look like slope is y3 minus y2, you see? Those are the y's that we got. And then divided by x3 minus x2. Put the numbers in, work it out. See, xy for 0.3 minus xy for 0.2. The short answer, or I think the best way to do it is within green here. Find them, label them, and then work through it in the regular way. Let's go back here. Yeah. One more look. Not there. What do we got? Yeah, another good looking one. These happen to be x-intercepts and y-intercepts, but we'll be doing more of that. This one's special, different from all the rest. What happens here? There are minuses there for sure. And so I guess the thing being from the west, I always look from the left and then going to the right. Okay, so when I look at a graph like this, I would say that this graph is going upwards when I look in that direction, right? And if it's going up, that means the slope will be positive.
Mm.
Oh, I can't see. I can't. Class can't either. Nice. So what I pointed out,
Yeah, no, I can see.
yeah, perfect. Being in the west, looking left, right. When I look in this direction, the graph is going upwards. You can imagine that you're going on a hike. So you're going to be going upwards in that direction, right? The slope will be positive then. If, however, the ground's going like that, if you're walking downwards, then the slope will be, as you can probably guess, all right, the slope will be negative. And we can check that with these numbers here just to make sure that it all makes sense. Yeah. So let's find the slope of this one. I think it's probably, and then we'll probably be good. Okay. So notice we got 1, 2, 3 points there. All we need are 2 points to find the slope, and we're good. Yeah, so for this one, 2 points. Which ones do you want to use? You think we can't? I know we can't. Yeah, we don't need to see the units for this one now, right? That's good. Okay, so 2 points. Which ones would you like to use? So -1 and 2. And what's the other one?
1 minus 2.
Not bad. 1 and -2. Zeros are pretty nice though sometimes when you get them, eh? So you can keep that in mind. Might be faster. Okay, we'll take a look though. What happens next? Label them, sure. X1, Y1,
Next one.
X2, Y2, just like that.
2. Mhm.
Yeah, formula for sure. And so because we got minuses now, hey, Peter, check this one out. Make sure he's there. Parsa, look after him. Give him a nudge. So minuses. So we're going to have brackets now.
2
Otherwise, drama.
2 over 1. Minus 2.
-2 in
Yeah.
brackets now, yeah. And then, yeah, I'm going to use your idea there, Zoom. Put these together. -2 over 1. Subtract.
Yeah.
And then Y1 and X1. So subtract 2 and subtract -1 like that, right?
Mhm. 0.
Zoom said 0. This is why we put the brackets in, to be careful, okay? It won't be, you watch. On the top, we'll do the bottom one first. That's probably the nicer of the two. Okay, so we got M is, when you subtract a negative, that's the same as adding a positive. Okay. So, and then on the top, we got -2 and then subtracting another 2. So where are we at now?
2 plus 2.
2 minus 2 on the top. Yeah, that's what we're checking out. What's that going to be? Yeah, these aren't multiplied. It's like -2 subtract 2. No multiplying though. Like these are subtracting from one another, right?
Here.
Yeah. That's correct. Yeah. Subtracting, adding, not multiplying. So if you're down 2 flights of 2 steps and go down 2 more, where are you at?
4.
No, not multiply. No.
Oh,
Well, that's just it. With 4, it's 2 plus 2 or 2 times 2. It's tricky. It's a sneaky one. Adding, subtracting. I know. What? Yeah. So adding, subtracting. -4 on the top is just short answer there. Okay.
mm,
Because you go down by 2, then you go down by 2 more. So you're at -4 now.
okay.
Yeah. So -2. Exactly. It's a rule that you can remember that when you subtract a negative, it just becomes positive. And so now this just turns into 1 plus 1, just like you see there.
Mm. Plus minus 1.
Over 2, yeah, absolutely. Final answer?
Oh, -2.
-2 from Zoom. Negative divided by a positive is negative. Peter, it's true. And then 4 divided by 2 is divided by 2 is 2. Okay. All right, good people. I think we're going to leave that there then. Yeah, well done. What do we got? A little worksheet for you to get started on. I think we'll do the odd numbers only. Okay, we'll save the other ones. I'll probably pull test questions from them. And yeah, that should be all right for the day.
Oh, that sheet, it's which day?
So a couple things, just a second. Zoom, this sheet is on Teams already. I put it up last day, day
It's,
22.
Okay.
So now I put it there so you can just take a look at it, but now it's there officially. Should be able to answer the questions. And then now from class,
This is the
yeah,
homework question.
we got to take a look at working with integers, eh? Is that the situation? Subtracting negatives and stuff? We need to look. Okay, what's -2 plus 7 going to be?
-2 plus 7,
Yeah,
5.
it's going to be 5 for sure. So it looks like this. -2 plus 7 is 5, right? So
Yeah.
how about -2 minus 7?
Okay. 8, 9. -9.
-9 from Zoom, that's right. So that's going to look like this. -2 subtract 7. So we get -9. Okay. How about this one? -2 plus -7.
Plus. Okay. That's
So we got -5, we got -9, -14. No, it's going to be, that would be with multiplying
plus,
times. So we're just plus here. -2 plus. So not times, but plus instead. No, check this out. Maybe this is new for you guys. That's what it looks like. Yeah,
That's
new, I
nice.
think. And so maybe watch this. This is when you add a negative, that's the same as subtracting a positive. So it's -9, yeah. Okay. No, it would be times, or I'd write that in there for this exercise here. And then there's what's the last one? -2 or -2 minus -7. It's going to be +5, but watch how it goes. You have -2 subtract -7 using brackets just to keep things nice, eh? And then because you're subtracting a negative, those are now added. And it goes back to our very first question. -2 plus 7 then, right? 5. Yeah. So slopes are easy except for this, eh? Okay. Well, we'll practice some of this then today. Make sure it's good. Yeah. Yeah. What time is it? Oh, it's pie time. Okay. We'll take a little break. 5 minutes or so. I'm going to stop the video, but I'll stay connected for for Zoom. Okay.
Please,
All right.
can you check my task
Yeah, I'll probably do it after class.
after class?
Right after class. Yeah. It should take me like a couple minutes.
Okay. Thank you.
Okay. Yeah.